All attendees are in listen-only mode.
Good morning, everyone, and thank you for attending this webinar. Today we're going to be presenting on 3D cities for safety and security. My name is Jeff Taylor. I'm a 3D solution engineer here at Esri, and I'm going to begin this webinar by talking about basically an overview of what CityEngine is and Esri's 3D technology, procedurally modeling a city inside of CityEngine, the process of doing that, and visualizing GIS data in 3D. Also joining me is Phil Mielke, and I'd like for him to give a brief introduction as well as some of the things he'll be talking about.
Hi everybody, Phil Mielke here. I work with technical marketing here at Esri. I'm a technology evangelist, and what I'll be working with really from a law enforcement perspective and a public safety perspective is first we're going to get into 3D crime visualization techniques. We're going to place some cameras and work within the CityEngine environment and start to do some viewshed visualization and be able to share that on the web as well. And then we'll also work with 3D for special event planning using our existing special event planning templates with ArcGIS Online, and then work through a workflow where we're actually able to bring that into 3D. We're going to be able to view evacuation planning and also have a web scene for that so that we can really use that as a communication medium. We're also going to model in 3D AVL and GPS analysis. This is a workflow that's common to law enforcement, as well as a line of sight risk assessment model.
A lot of fun stuff today, so be sure to type any questions you have during this webinar in the question box, just in that panel on the side of your screen, and we'll try and get to them as soon as possible at the end of the webinar. Like I mentioned, a lot of stuff to cover, so let's go ahead and dive in. And many of you may be wondering, what CityEngine is, exactly what it can do for you, and why you should be using it. So let's begin with a brief overview of CityEngine. So with CityEngine, we can create beautiful 3D cities very rapidly. We can create cities in ways that people can understand, so that added fourth dimension, such as zoning, or even create effective visuals of stormwater infiltration or other environmental effects. And CityEngine and our 3D technology has been used in several different industries over the years, basically starting with mainly the media and entertainment, film and gaming, and television industries, bridging further now into the architecture AEC market, urban design, and design viz side of things, and even with safety and security, training simulations for military, local governments, and in cities GIS, and that's really rapidly emerging. So we're having a lot of 3D cities starting to show up across the country. So with CityEngine, we can even create futuristic cities. So for those gaming applications or entertainment individuals, we can help them with this. We also create historical models of what used to be. So it's not just today, it's also temporal, it's the past, different things there. And we can create realistic cities. So this could be your backyard, your environment around you. And we can model this, and as Phil will be showing later, crime in that fourth dimension with models just like this. So you may be wondering, why procedural? Well, with 3D, we run into a problem, and we need to rely on rule-based modeling instead of manual hand modeling for this. So in the past, 3D has been time, labor, and cost intensive. You have to manually model a lot of different things by hand. And the process of modeling is very tedious and repetitive in that way. And creating multiple iterations is time-consuming and difficult because sometimes you just can't edit things that you've already made in 3D without affecting the model negatively. So there's all sorts of things coming into play there. And the solution to this problem is procedural modeling. So if you're only modeling a few buildings, then it's easiest to model them by hand, maybe a very iconic tower or something like that. But if you're modeling several buildings, a district, or cookie-cutter repetitive buildings, or an entire city, then procedural modeling is definitely the way to go. And with procedural modeling, you can save both time and money. Not only this, but procedural modeling also provides a flexible 3D design environment supporting a rapid, repeatable process, particularly when projects require many iterations. So This process includes, first of all, authoring what we call rules in CGA, which are if, then, and, or code functions, which tell buildings how to be shaped or streets how to be shaped or any other asset of the environment. We can then generate multiple design scenarios and evaluate alternatives. So procedural modeling is not just about creating 3D geometric forms. It's also smart and intelligent. Esri's procedural solution connects to a data-centric, rule-based system working off of common databases and views, allowing for multiple ways of viewing data and the world. And since it's smart, it also allows for intelligent real-time performance reporting to be calculated whenever changes are made to any part of the model, which is very valuable for planners and people maintaining city databases. CityEngine even supports rapid generation of multiple scenarios. So if you're creating a new development, we work well with this, such as this example that you're seeing here from Honolulu. And this would show potentially what an area could look like for suburban sprawl, so we can tie other GIS data into creating a 3D city. And with CityEngine, you can also export the 3D models you build for sharing on the web, communicating and collaborating on projects internally within your organization, with the general public, or with shareholders and stakeholders. And these web scenes can even be embedded within your own website. And Phil will give you a great overview of this with crime layers later on. And later in this presentation, we'll cover just that. So what are the steps to modeling, let's say, my city in 3D? Well, with CityEngine and Esri's technology and the procedural core that's been pushed into ArcGIS 11, you can easily take 2D vector data and transform it into a 3D model with a few simple steps. So step one of this process is basically importing or the creation of 2D information within either CityEngine or ArcGIS, so creating that GIS data or taking it in from third parties that have created it. And then importing is step two and creating 3D streets, city blocks, or even parcels at that point. In step three, we use the procedural rules within CityEngine, those capabilities, to help automate the 3D extrusion process of these shapes. Step 4 deals with texturing and further refinement of the structural facade styles and other elements on the buildings for more added realism. And in Step 6, this has to do with exporting it back to the file geodatabase, taking it to a third-party rendering software, or exporting the model to a web scene for sharing, communication, and collaboration. So we can interoperably now work within the ArcGIS platform with these 3D city models that you've created, so nothing is wasted with the final product. And in even simpler terms, this visual shows the process of extruding the 2D data into a smart 3D city model. So I want to dive straight in and show you how anyone can create a 3D city using Esri CityEngine. But before I do so, I'd like to provide a brief overview of what today's demo is going to include, at least from my end. We'll begin by walking you through the process of creating a 3D city. And this 3D city model can be used for assessing 4 out of 5 of our related needs that we will cover today. We're not going to cover underground visualization just because of the time constraint, but you can take the 3D model and conduct land use assessments, economic development, zoning regulations, and then Phil's going to talk later today about safety and security, as mentioned earlier. So let's dive straight in. So if you go to esri.com/CityEngine, you can download the free trial of CityEngine, which is our flagship product for 3D city modeling. And you can download the 30-day advanced version of this, which also includes our new SDK, our software development kit, which can run inside of Maya as well as other 3D modeling packages. So you're not just limited to the Esri platform. We also have resources to help you get started and information about the industries on this website as well that you can find. There's also a CityEngine ArcGIS Resource Center containing lots of templates, training, anything that you need to get up and started with using CityEngine and creating 3D city models are all at your disposal here. We even have workflows for using ArcGIS or how to even program in the CGA language, but we're going to have all the examples that you need where you more than likely would not have to even program anything in 3D to be successful with CityEngine. So just a quick overview of some of the resources available. So when you first open CityEngine, and this is the new version, 2013, you get this welcome wizard. So you can set your navigation style. It gives you an example of the resources available. You can download example projects here as well. And then we can create our own city for the first time. We can give it a name, choose the city layout that we want to have, and pick a rule style for it. So in this case, we'll choose the new International City Rules for 2013. which just came out last week. So the city is going to start to generate in the background just by pressing this option. And this isn't a real-world city, but it's more of a geotypical city or more of an entertainment type city that you're seeing here, where we create street networks procedurally and we create parcels offsetting in these street networks and then apply rules to create buildings. But we can use these procedural rules to create very realistic cities procedurally. And we'll show you that after this example. So you can start to see the concept of the 3D city model generating here just randomly by the types of rules applied to it for if it's going to have a tower, a residential building, or trees within a specific area. And we'll let this generate here for a little bit longer. So once it's generated, I can then select one of these geometries or these parcels, and I can change some of the attributes on it for the way the building is laid out, such as the height. I can choose the type of building it is, and this is how procedural rules work. The magic happens in the inspector, and you can modify almost any value or variable, making the geometries align to what you want them to look like for a specific city or specific area. And you can even select streets, change the street widths, edit things on the fly, and everything adapts to these changes with these dynamic layouts. And then not only that, we can also do editing or creation of GIS data and information inside of CityEngine. So we can draw streets and they'll automatically create parcels. For a new city, this is great. For existing conditions, you can also import parcels and other things around it. And we can also draw building footprints manually, like multi-patch editors, and also continue to draw new 3D forms, pull up roof planes really easily with these intuitive and intelligent interfaces, and make models that way as well. So let's start by creating our own 3D city of a real place. We're going to model Redlands, California. That's going to also roll over into Phil's examples for the city as well for safety and security. We're going to select our coordinate system when we create a new scene and then click OK. And we're going to be using a lot of existing assets that you can find on the Resource Center to help you to create a 3D city model rapidly. So then I want to drag in place my terrain file in, my digital terrain model, my digital elevation model, and then I can choose an ortho image to drape on top of that very easily. And it'll put it in the right coordinates, and it'll be that 3D terrain, just as you'd have inside of ArcScene or our other capabilities with 3D. So once you have the terrain in, the next step is to bring in your vector data or your building footprints, streets, lights, or trees. And all those can be brought in just by clicking a few buttons. And you see them placed on the 0, 0 axis. So then we have to choose, okay, to project these on top of that terrain file. And turn off and on the street layer so the streets all show up. And then we can select the trees, and we can align them to the terrain just by clicking a couple buttons. Everything drapes automatically. And then the buildings, so we can align them to the terrain as well. So let's translate those to the minimum, so it makes sure that they align flat on the terrain. And then we're going to select an area of the downtown and just select the streets, because we don't want to generate all the streets because it would be a very heavy model. But we want to create a large chunk of the downtown area and run a street construction rule. And this will make these streets turn into 3D streets. You can use your city's data attributes to set the widths automatically, and other information to really help speed up this 3D modeling process. So with the trees, the same concept. We'll just select the point data where the trees are, apply a rule, and it'll then automatically generate trees in this case. You can use real genus species from what the city's inventory has, or you can specify a random range of different tree types there, such as we did here with palms and deciduous trees. And then on top of this, we can also apply a building rule, so a construction rule, and use the height data that we can use derived from LiDAR information, and use that to tell how tall the building should be. And what you're seeing here is the generation of this 3D city procedurally taking place once the rules are all applied to the 2D GIS data. And this is a really randomized color schema that we use just for this example. You can pull from the imagery color below it, or even have buildings that have textures on them. This is more lightweight in this case for a very massive environment for analysis. So let's let the city continue to generate, and it'll make the entire model all the way up to the mountain edge here. So this is the procedural process, and while this is taking place, you can go grab a coffee to kind of relax and let the computer do all the work. Okay, so now we have our 3D city modeled. We want to then go through and generate some of the other assets, such as the streets, and they'll quickly generate, and then the trees. So we'll start to see some vegetation show up in the middle, and these are new vegetation coming from Eon Software, which is basically the expert company in digital nature. They've been involved with several movies and games in the past, and we're now incorporated a tree library from them into CityEngine. And this is the final product of that model. So we can even take in third-party models in Collada format, file geodatabase format, or other forms into CityEngine. And what we're looking at are pictometry building models that were easily loaded into CityEngine for more added realism, which really help with safety and security types of analysis, such as line of sight or other things, for more accuracy. And then even the vegetation here, we have an option where you can choose to create the 3D volumes of them, or the 3D forms as you see now, allowing for more intelligent line of sight or other kinds of analysis as well. So that's a quick overview of the 3D city creation process and how quick you can make your own city using existing procedural rules. And the accuracy is just limited by the time that you have. So not only can we then harness that model to visualize what's existing in the city, but we can also visualize the fourth dimension, as I mentioned earlier. So we can look at the land use types. So we can see what's commercial, what's residential, what's office space, on the building geometries, but then we can also select the parcels, the footprints below them, and thematically color those as well, and they will respect the same zoning usage. So it's more ways of creating discussions and understanding data that we haven't really been able to accomplish as much in 2D or in existing 3D technology that can now be done in the third dimension. But it's not just limited to building footprints and parcels for coloring those thematically by the zoning uses or other attributes. We can also create 3D zoning, which is a big new push for sustainability right now. And with this, what you're seeing are the parcel areas, the setbacks by city regulations, and other information, and the usage types, which limit how tall a building should be, or other forms. And we can then start to edit these and see, what would these changes start to look like for a city, and get reporting metrics on these using CityEngine and even ArcGIS. And we have workflows for how you can take your city's data from a spreadsheet into a file geodatabase for 3D zoning on the Esri platform as well to speed time up for production purposes. And then not only are we limited to just that kind of data for 3D thematic visualization, we can also start to look at other data such as census block groups or any other kind of vector information that contains values. And we can thematically color these and make better meanings out of them in 3D. So we can extrude these volumes using a specific range that we specify, and it'll take whatever the values are into consideration there and just optimize them. And then we can change the thematic colors. We can even change by different attributes or different settings in the data, and the model will inherit those changes and give us a little more in-depth visual of, the effects of information on society. So that's just a quick overview of what you can accomplish with CityEngine. And now for the moment we've all been waiting for, I want to have Phil speak about some of the amazing work that we can do for safety and security.
Hi. So my name is Phil Melke. I have a 12-year experience in law enforcement and crime analysis. Actually here in the Inland Empire, working for the city of Redlands as first a Compass analyst. It was a grant project really to combine databases for the Inland Empire. And since then I've had the experience as a GIS supervisor and an interim CIO for the city of Redlands. What I'd like to do is share some experiences with you as far as how to be able to work and understand the value of 3D here in this case. And I'm going to begin by working with 3D crime visualization. So this is another technique to be able to work with, and I'll show you a little bit of what our world normally looks like here in this case, here within the ArcMap environment itself. There's within the police department, in the CAD and record system, there can be hundreds of thousands of points of information that's collected. And our main issue here is to actually pull something valuable and of meaning out of it. And some of the typical workflows that we end up being able to utilize, either working with kernel densities or other forms of statistical analysis, actually produces something that is a little bit more meaningful in this case. And here's a representative example of 2 years' worth of assaults. And this is used to really identify where it is that we can place patrol, or potentially also some more problem-oriented policing or community policing projects in some of these areas. If we know that assaults are high in a specific area and we're able to communicate that outside of the police department, we can use the community and leverage the community a little bit more as a partner in this case to help to reduce crime. So the question really is, how is it that we can get this into 3D so that we can then share it as a web scene and have other people to be able to visualize and be a part of this process of understanding the volume of crime and the trends that are occurring in their community? So what I'd like to show you here, this is a geoprocessing task, and this is something in Model Builder, something that's available here within the ArcGIS platform, where we're able to take those individual crime points and produce this density, and eventually then produce points that we're going to use in order to visualize here in 3D. And so I'm now going to show you here what this ends up looking like within CityEngine. So there are this is our 3D environment of Redlands right now, just taking it off where Jeff left off. So once that work is done, now this is a way in which you can end up sharing a lot of individual pieces of information on top of it. This is commercial burglary here in this case, using individual points that are borrowing values from that density that we were just showing before there. And similarly here, this is residential burglary, and we've got vandalism. And we can also see theft and the volume of theft that occurred here over a 2-year period, and also our vehicle crimes. So getting a bit of a sense as far as visualization helps us to go a little bit deeper into the problem and understand really where is it that this, what are some of the actual features that could be potentially causing this. But aside from that, what we really want to be able to do is use our analysis product to really be able to procedurally model and borrow from our density values what these actual buildings and streets look like as far as the volume of crime in an area. And so here in this case we're looking at our vehicle crime problem, and we can pinpoint specifically which buildings are a greater issue here. So aside from that, the value of 3D could be really used and brought into this potential of us needing to be able to understand where it is that we're placing placing video cameras and CCTV systems. So for police departments, really, we end up calling this a force multiplier. As our budgets go down and our potential for crime in some areas can be increased, what we really need to do is leverage some other technology in order to be able to understand better where it is that we're placing our cameras. Or for the potential of development, what I see happen is this communication. It's a two-way communication between law enforcement and our planning departments. So when a new development is taking place, what we really want to be able to do is start to understand a little bit better where it is that we want to be able to place those cameras and to view those. So here within the CityEngine environment, what we're doing is just placing a shuttle route down, and we want to make sure that this specific area is well monitored here. So using some specific rules that we have for camera control, we can change really what our view angle is, and as well as where it is that we're looking and the tilt of the camera, but also the direction of the camera placement itself. And so this would be really a collaboration technique to walk through and understand really where it is that we're placing our cameras. So in the long run, we end up in agreements with the planning department itself. So I want to show you also this shared within this is a CityEngine WebGL viewer. And so here what we're viewing is actually our 3D camera environments in our view sheds within the city of Redlands. So this was a big project that we had where we really wanted to be able to understand the placement of these cameras to make sure that we've got really as maximum coverage, and we're leveraging the investment that we've made. And we're also leveraging the investment that we've made here within 3D. So this is something you can see here that is viewable within a browser. I can share this really with anybody that I choose, or I can also choose to keep it safe within the ArcGIS Online environment. And so that using this, we also get a sense of really how to be able to mine some of these video cameras forensically. So if we happen to have, like we did just recently, a series of bank robberies, we can kind of understand a little bit better and visualize some of the cameras that may be crossed in an exit route that's happened there, so that we can understand and maybe potentially get a suspect or a vehicle description and use that for the process of further hunting down our bad guys here. So this is just a quick view of some of these individual video view sheds. So I want to give a different example here. Is actually we're going to go into a special event planning template. So this is one of our solutions that we make available on solutions.arcgis.com. And so where we've got this scenario where here within Redlands we've got a large event that's going to be playing out. And we want to be able to better plan for it here within a web map environment. So this is ArcGIS Online for organizations. And we're really leveraging the ArcGIS platform here to be able to use this as a two-dimensional collaborative platform for being able to plan a little bit better and understand where it is that we're placing all of our assets in the field, where our streets are closed and where we're placing barriers, where the location of our first aid, bathrooms, a lot of other assets that are necessary in the field. So this is all well and good, and this is really helpful, but what we actually want to be able to do with this is visualize and share this a little bit more within 3D so that for a briefing process or a debriefing process, we can get a better sense from this collaborative 2D environment really what our plan is and how it is that we're going to be working this large event. So here we're taking these assets and using rules-based modeling, we're actually able to take these points and extrude them within a three-dimensional environment to get a better sense of where our full three-dimensional plan is, so that we can talk through the placement of our dining areas or our parking areas. And so by using this, we can actually change some of these on the fly and share it here within a web environment itself. So that's an example on how to make a quick, just go from a two-dimensional to a three-dimensional process. Got another example here where we're going to be showing a view shed modeling and a line of sight for risk assessment. And the scenario that we have happening here is that we need to be able to better understand what is at risk potentially from the water here. So we're working within the city of Singapore here in this case, and we're doing and using our three-dimensional modeling tools within ArcScene to first be able to identify the skyline it's one of the tools that we make available. So by being able to first model the skyline in this one initial instance, what we're actually going to be able to do is stretch this out so that we can understand the skyline risk assessment in 3D. So we're looking from one place now here on the harbor, but now you can see this change a little bit. So as we're going to be moving across or simulating the movement of a ship, we're trying to understand our risk assessment from attack, potentially from water here in this case. So if you've got a large event or if you've got a VIP that's visiting along the waterfront, we're going to be able to better understand where it is that we have a risk of sniper or something else that might happen specifically from a boat. And the thing about a moving potential threat is that risk assessment is going to change through time. So we need and change through travel. So we really need a method of being able to have a moving window of this skyline or this risk assessment. So this is another geoprocessing task that's going to produce that for us here. And so as we're moving through this, what we're going to be able to have, it's going to produce, it's calculating a series of rosters and vectors in order to be able to produce for us an animation of this skyline risk assessment here. And this is a really impressive visually at once here, as we'll see. So this is our moving threat, and as you can see it moving just right here from our central point as from a ship. And so we're calculating over and over and over again what that skyline view is and also that risk assessment, what's visible from that ship, so that we can better understand and better calculate a surface that will help us model and identify really what are our risks from that individual river there. So by being able to produce this, this actually becomes meaningful information for that larger sort of special event planning template, and we can bring this back, do the analysis from 2D, and actually bring it back into a three-dimensional environment here. So another example here, leveraging some of that 3D, that rich 3D content that was created, now as another public safety example, is a method of being able to communicate an evacuation plan. And here, this is something, again, that we're sharing through online through the WebGL viewer here, so that we're able to see that we've got a building, and we're identifying our full evacuation plan in detail here from a web browser itself. So being able to see rich 3D content within a web browser and be able to share this as a link with your, say, your staff that's within this building. And here it is, we're actually running through step by step these individual scenes, how it is that you would take an evacuation plan and what that would look like. So the process of actually modeling this within 3D itself helps the person visualize really what it is that their path is going to be a little bit better, so that you can get a better sense of communicating and educating what an evacuation plan is, because there's nothing better than having a little bit of foresight before before you have an actual need or disaster that ends up occurring there, and you need to be able to evacuate the building. Education, practice, these are all things that help that process of being able to understand really public safety. And we understand this better by practicing. So one other thing is that we can also, if we happen to be missing any of our friends that hadn't quite evacuated yet, we can query some of this, or we can actually search for individuals or for individual assets here within this three-dimensional web scene environment here, and actually be able to zoom directly to that. So we can use this WebGL viewer here as a method of being able to really walk through and as a search method as well too. Okay, I've got one more example here that I'd like to show, is using some of these web scenes as well to better understand our potentially some complex information within a three-dimensional environment. And the reason why it is that we're using the three-dimensional environment to actually visualize some of these things here is that this, for example, is GPS tracks through time. And we really want to be able to visualize time as that third dimension, as that height value here. So this is 1 day's movement of an offender that's moving around, that's being tracked, and we're trying to understand really where it is that they're spending time and how it is that they're traveling from place to place. So we've just used a couple of other additional visualization techniques here. In this case, we've buffered those individual lines by the speed of travel, so that we can actually use another dimension and visualize an analysis product here, so that what we're doing is, as we're seeing this offender move throughout the city throughout the course of the day, we can better get a sense of their speed of travel, where it is that they're spending time by these areas that are persisting through time, and understand places where they're coming back to and how frequently this ends up occurring. So by using this, it's a way of being able to expose rich analytical content within a three-dimensional environment in a way that really all of this information would be cluttered and very difficult to understand unless we had this ability to be able to extrude and use this within a three-dimensional environment here. And so as we move into understanding deeper value to larger data sets, we're going to need methods of being able to visualize them. I believe truly that three-dimensional visualization is going to end up being that. And another example here in this case is actually measuring the volume of where it is that a group of AVL data, several units being tracked, where it is that they're spending time over a 7-day process. And so this is 7 days ago down here at the bottom, and this is just recently now. And so we can understand really where is it that where are the persistent locations where time is being spent on patrol, but also understand where is it that some of these areas are getting attention just from time to time, some individual locations itself. And so by being able to model this larger data set, really in this case we're dealing with just under 70,000 data points. This is a way of being able to aggregate this and bring it together in a way that helps us to better clearly understand some analytical content here. And so with that, these are a couple of 3D examples. I appreciate your time, and we'll look forward to more coming from us here in the future.
Hey everyone, well thank you again for attending this webinar. So at this point we'd like to open the doors up for questions. If you have any questions, please enter them into the question box. There's several ones that we already see active right now. And on behalf of everyone at Esri, thank you for joining this webinar. If you'd like to schedule a 3D meeting, please go to the following URL, esri-link.com/meeting, and I'll continue to add more and more meeting slots in the new year to that list of available days. So if you want a personal conference call or conference meeting, definitely sign up for one there, or send me an email as well after this webinar, and I'll follow up after this webinar with more information for you as well. So let's dive into some of the questions. All right. So anything you have for myself or Phil, feel free to enter them in, and let's go into some of these. All right, so to start out, can CityEngine or its web browser respond to data changing over time in an emergency response scenario, which could be positions of vehicles, personnel status, or buildings or rooms? The answer to that is currently no. It's more of static modeling right now. We do have GeoEvent Server on the Esri platform, which is going to be able to pull real-time data feeds into a larger 3D globe system once that's out later this year. But currently we can only deal with static data sets, but that is coming here in the next several months. So another question was concerning ArcGIS 11, and is it compatible with CityEngine, and what are some of the overlaps? 11 has the procedural core that's inside of CityEngine also installed within it, so we've fully integrated some of the procedural capabilities there, and you can write rule packages or RPK files that can then run inside of ArcGIS 11, so you don't have to do all the work from CityEngine. And whenever you update a building attribute or a street attribute, the geometries adapt to those changes. All you have to do is run a GP tool, a geoprocessing tool, on the 3D models there. Okay, some other questions here. I got a good question for you, Phil. How can I use data to track fires in different locations?
Okay. Well, in this case, there's actually a couple of different things that you can leverage and view within a three-dimensional environment here. So individual fire points is very similar to what we're working with within a crime database, where it is that we're needing to either model individual points of these fire locations, or in a larger setting, the change of a fire boundary over time. Additionally, one of the things that you can work with here within a three-dimensional environment is the potential of showing fire risk layers. So in a lot of cases here, especially in Southern California, where our largest risks happen to be within the mountains, understanding a three-dimensional environment and the potential that slope can play on a fire movement is very important. So working first within a first within a two-dimensional environment to produce an analysis result, or using some of those characteristics, slope, or what fuel is available. Ultimately, what that can end up leading to is to then visualize that within 3D so that you can better understand where it is that you're going to place your resources and keep them out of harm's way within a three-dimensional environment. And you can also share that from one organizational facility to the next here with these lightweight web 3D viewers.
Awesome. Great answer, Phil. So another one regarding cities in general. Can we see underground utilities in CityEngine? And yes, you can see them. The key with utilities is you want to use ArcGIS 10.2 or 11 when it's released and run inside of ArcScene operations to take the 2D data and turn it into 3D, just because we can't model pipes inside of CityEngine. You can then export those as a geodatabase format or a collada model into CityEngine and view those with the buildings, or you can take your building from CityEngine into ArcScene and visualize the pipes in relation to those and those utility lines to the city. But CityEngine is definitely not a utility type application, but it adds the value to that information, and once they're generated, can thematically flag those as well for more meanings. So some other questions? Yeah, another one on gas and water, the same kind of concept there. So yeah, for safety security, you could flag variables or attributes on those pipes and infrastructure lines that have a higher risk of maybe a terrorist attack or something else there. So authoring complex rules in CityEngine. So we have a lot of those rules on the Resource Center, as mentioned earlier, available. The new City Wizard rules are very easy to use, and they have imagery placed on the sides of geometric forms that you can customize those further. Or we also have business partners ramping up rule creation, and I can get you in touch with them as well if you do have any interest in that. So you don't have to do it yourself. But we pretty much have most everything in the box that you need to start to create your 3D city without having to do this coding, unless it's a very complex situation. So another one on utilities. There's a lot of interest in that today. Great to hear that. So another question on, well, this is one on GeoDesign. How can CityEngine be applicable there? Well, I honestly think of it as the planning process for larger district areas or something else in the sense of CityEngine or urban design. And what we can do is start to draw the street networks, subdivide parcels in the middle of that, and other things. And I'd recommend checking out the CityEngine YouTube page. Just go to YouTube and search for CityEngine, and you'll find some videos from a couple webinars I've done over the past few weeks showing the process of creating a new development in CityEngine and going through the whole GeoDesign process there. And we also presented a very great presentation at the ASLA Landscape Architecture Conference on just that as well in November. All right, so question on indoor modeling. Yes, so on the Azure platform we can do indoor modeling. I'd also recommend to look back at one of the more recent webinars we've had. I think it was the one in November on the YouTube page, and it goes even further in depth on how you can model interiors. We can work with BIM data. Save Software just released a great plugin to take IFC or BIM into the geodatabase, and then there's some other capabilities there for just taking CAD data into the local government data model that we can do as well. And then we also have jump starts to help with that process and make it fit your workflow on the Esri side of things if you have an interest in that. So how does the web viewer synchronize with CityEngine and ArcMap? Phil, do you want to take that one?
Sure. So you can actually publish from both applications. CityEngine itself will allow for a little bit more complexity to your three-dimensional model, including, say, the facades of your buildings. But you know, if you're a regular GIS person who's used to working within that ArcScene environment, we have a geoprocessing tool that you can just search for there and identify and find CityEngine, or be able to convert from an ArcScene document to CityEngine itself. So once you've got what's called a 3DS file in this case, you can upload it there to your ArcGIS Online account, and then be able to choose to share that internally or externally. So there within that three-dimensional environment, that lightweight web browser, you have a lot of different types of functionality. Be able to remove different layers or visualize different layers, or to be able to change your lighting so that you can really kind of do some really rudimentary analysis to identify what kind of lighting you've got in the area as well too.
So we have a few questions on licensing of CityEngine, our software. Domestically, I can speak for that, but internationally, you'd have to get a quote from our business partners on that. If you're a student in the United States, we have a $100 license. The $500 basic version of CityEngine is also domestic here as well. And then you have the advanced version that you can also view these prices online or contact a business partner in your location. So that's another question. Another one has to do with hardware capabilities required to operate CityEngine and model in 3D. As far as a graphics card, I recommend the NVIDIA OpenGL supported graphics cards if you're using a desktop, as well as a laptop. Those really help as well. So basically a heavy CAD type card would suffice, and a lot of the computers you're using for GIS typically have these. And I also really recommend the 64-bit processor because huge cities take a lot of power. And then personally, 8 gigs of RAM would be great. You can work with 6 or 4, but 8 or more is ideal for making sure that you can model quickly and efficiently on that side of things. So those, hopefully that helps to answer a few more questions. I guess, Phil, do you see any other questions on your end?
I'm afraid I don't, no.
So last one that's here I'm seeing is a question on LiDAR. Do we support LiDAR within Esri and CityEngine? We do support the last file on ArcGIS, and you can take height values from LiDAR and apply those to the tree points that you have for a city, the building footprints you have for a city. But we also have business partners such as Overwatch and others that can do extraction of footprints from imagery and extraction of footprints from LiDAR information, or business partners that can make 3D models such as a Pictometry or CyberCity 3D that can help with your 3D city creation if you want higher realism than a typical procedural model. But the more time you spend on modeling procedural rules and using them, the more accurate your city will become procedurally, and it can cut down on costs required to model a city in 3D. So let's see if there's any other questions. Another one, last one is on Mac's iOS support for iMac, and can we load Webscenes onto those? Well, in tablets, well, we can load on the Android tablets, Microsoft tablets, a good chunk of the newer ones, but Apple still has not opened up the ability to pull WebGL into anything other than advertisements, so we're still waiting on that to come out. But with a 3D runtime later this year, that will be able to run on any device, so we'll have a Globe service that can then run at that point. But for now, it's going to be a little bit longer on running it on iOS. But everything else you can run it on Android or Microsoft tablets, and you're good to go there. So, all right, great. Well, it seems to be all the questions and most of the time we have today to answer these. I guess just follow back up with the email we send out after this webinar if you have any other further questions or would like to schedule a 3D City meeting, and we'll get back to you soon. Well, thanks again for joining.